Hello and welcome back. So today I'm going to be focusing on the use of equal to default and equal to delete. So I can explicitly ask the compiler to generate a default constructor. So this is how I do it. And I can also do the same with the copy constructor. So I just say equal to default. So that way I'm going to tell the compiler to generate the default versions. So I could also do this with the assignment operator equal to const my class. So this tells the compiler that it should be generating the default versions. It should be synthesizing it. So I don't need to write any code here. And I'm explicitly asking the compiler to do it. So there's a little bit of test code here that I've written. So I'm creating two objects and then I'm calling the display on them. So let's see how this goes. So as you can see, yeah, so we have got the value 10 for both the objects. Great. So let's now try assigning object 1, object 2 to object 1. And let's once again call display on it. So as you can see, once again, the value is 10. Excellent. So now let's look at the other end of the spectrum. Let's assume there are cases where a class doesn't need to have an assignment operator, and it doesn't need to have like a copy constructor. So in that case, this is what I will do. I will just say equal to delete. So I'm instructing the compiler not to generate any default copy constructor or a default assignment operator. And as you can see, the ID has already signified an error here. So let's go ahead and see what the error is going to be. And so as you can see, the error is my class, the operator equal to attempting to reference a deleted function. So in other words, we have told the compiler not to generate an assignment operator, and so that's the reason you see the error. So similarly, if let's say I want to sort of call the copy constructor, so I can do like my obj3 is equal to say obj, sorry, not, so I can say obj1. So as you can see, once again you get an error. That's because we have also deleted the copy constructor. So this is quite a nifty feature where you can tell the compiler not to generate any synthesized versions. Now you could also call delete the destructor, but then you wouldn't be able to define any variables. So you would be able to actually dynamically allocate memory for an object with a deleted destructor. But what you need to remember is that if you delete the destructor, there will be no way in which the object would get destroyed. So the object is going to persist in memory. So you need to be careful when you try deleting the destructor. So what I'm trying to say is like if you do something like this, okay, and you say delete. So this is going to tell the compiler not to generate the default destructor. So no object of my class is, you're not going to be able to destroy any object of my class. And as you can see, you can't even, the compiler will not even allow this um, program to compile because it's not going to be able to destroy any of the objects. So, you can't really define an object here. All right, but you can always do this. Okay, so let's, all right, let's do that. And let's do an OB pointer display. So as you can see, the value is 10. So even though your destructor has been deleted, you can still go ahead and dynamically allocate memory. But it's not possible to uh, try and do this where you actually try to define the object. So if you're actually allocating it on the heap, that's going to be possible. But one thing you need to remember is now this memory that has been allocated, you're not going to be able to destroy the memory because you have deleted the destructor. So usually this is not something that you would want to do. I just brought it in here for the sake of completeness. All right, folks, that's it for this video lecture, and I'll see you in the next one.